Okay, well, hello everyone. It's great to be back here at NEARCON with all of you here in beautiful Lisbon. So my hope is that this talk will ease us into the theme of how AI and blockchain intersect. So a history of AI and blockchain can be told through the game of chess. In 1997, an AI chess engine called Deep Blue famously defeated the grandmaster Garry Kasparov. And Deep Blue wasn't intelligent per se. It couldn't produce strategy, but it could calculate over 200 million chess moves per second. So this was a watershed moment where AI caught the public's imagination. And since then, AIs have defeated the best players in games like backgammon, Jeopardy, and as portrayed more recently in the Google DeepMind documentary, Go. Here we see the champion Lee Sedol capitulating against the AlphaGo program. So we're captivated by these battles for humanity, seeing generational talents, humbled by the superhuman skills of AI. When Lee Sedol retired from professional play in 2018, he stated that he can never be the top player of Go due to the increasing dominance of AI. He referred to them as being entities that cannot be defeated. So as the saying goes, technology is a mirror. And when we look at a reflection, what do we see? Whatever it is humbling. In light of AI, we're realizing more than ever that humans are endowed with modest cognitive capabilities. And for the time being, and with a degree of caution, we can safely say that AI is endowed with less. As John McCarthy lamented, as soon as it works, no one calls it AI anymore. So cognitive scientists once believed that studying the brains of the best chess players would reveal the golden secrets of human intelligence. To defeat AlphaZero, which is the best chess engine in the world today, you'd have to make a move so brilliant as to defy all expectations. Such AI research shows that human intelligence is one part computational brute force and another part more creative, intangible. So AI, or the designers and developers of AI, value surprises. That is, when you've taught it something. In financial terms, this is an arbitrage of intellectual capital. So at the moment, we have this opportunity to trade our human skills and knowledge for money. The AI wants our knowledge, it wants our information, knowledge, maybe eventually wisdom. And of course, we want money. And note that this is already happening. This is a picture of a mechanical Turk, which is an automaton chess player, which was invented in 1770. As you can see, there's actually a human being inside the box, masquerading as the robot. But the Mechanical Turk is the namesake of Amazon Web Services' crowdsourcing platform. And AWS has created new labor markets to monetize the human skills and knowledge necessary to develop AI models. There are a lot of problems with Mechanical Turk, not least of which is the underpaying of the labor. At the same time, it's also been a boon for various researchers. Academics can now perform studies with people all around the world. They're no longer limited to the undergraduates in the universities that house their research labs. And here's what Yann LeCun, who won the Turing Award for his work on convolutional neural networks and computer vision, has to say on the subject. He tweets, "Human feedback for open source large language models need to be crowdsourced Wikipedia style. And it's the only way for LLMs to become the repository of all knowledge and cultures. As we know today, AI is centralized and biased towards the English language and Silicon Valley. So there's an imperative here at a global scale. What we're seeing are gig and creator economies on the rise, and this signals new ways for people to monetize their skills. In the ongoing trend of digitizing real-world assets, you can think of chunks of human intellect taking on the form of these digital assets. And so this is a technological question. What are the technologies that can be accessed on a global scale which are capable of transferring value between humans and machine agents? And I think you know where this is going. Naturally, this leads us to blockchain. So blockchain is assumed to provide all of these different solutions to the world's problems, many of which we've found to have failed, some of which have succeeded. But one thing that we know that it's good at, and that it's endured, is that it's good for making markets. And in this case, the markets are for global intelligence. So if you look at these first drafts of regulations being proposed by governments around the world regarding AI, there are mandates for data privacy, there are mandates for safety mechanisms and risk. If we look to blockchain, of course, there is the need for those principles that make human collaboration and competition fair and transparent, and they must be reflected in the mechanics of the game. And of course, the technology needs to be efficient because it needs to address the problem of underpaying humans for completing these human intelligence tasks. So here is an idea graph, hopefully that can start to illustrate what this market looks like. So the market for crowdsourced human intelligence is two-sided. On one side, we have the task providers. These would be AI companies. They have provisioned a bunch of data. They need them to be annotated with the knowledge of humans. And of course, they're depositing some money to compensate the workers who will be performing this work. And on the other side, we have the workers. They come from all around the world. They span demographics. One interesting case is that you have retirees who take this kind of work because their benefits don't cover their cost of living in the later part of their lives. And from the perspective of game theory, both sides will attempt to pull the rug from under each other. A worker could produce junk, yet feel entitled to earnings, and a task provider could receive quality work, but withhold pay by claiming the opposite. So each side will devise strategies that the others can't thwart, and this is known as the mini-max principle. And what these technologies that we build, these decentralized technologies, do is that they keep asymmetries of power in check. It's the goal of the mechanism design. And so what we're trying to show is that work will be assigned by the provider to the workers based on an evaluation of their competency, or they can hand select them. This is basically a security question. What kind of proofs do you need to create this contract of employment between two parties? You could do proof of authority, where you have one entity handpicking people, but as the industry shows, this is an onerous process. It's costly. You can do something like proof of stake, where people stake capital in order to have stake in the game, but given the demographics, these people don't have money to stake. They're making this money to make a living. So the work must be submitted without cheating, and in turn, it must be evaluated fairly and be compensated for. So there's an interdependence for the system to work properly. You have to reform what's called the central inspection principle. This is the idea by Samuel Bentham that talks about how you can efficiently manage a large number of people with few supervisors. And you also need to maintain Sybil resistance, a concept we know very well in blockchain, so that workers can't spoof the platform. So this is loosely analogous to a proof of work model, where the work performed well translates to earning reputation, which leads to accessing further opportunities. And we can commit these proofs of work and start to measure reputation on the chains. And so here's just a video animating the distribution of tasks, workers working those tasks, submitting them to the market, and eventually they get paid. Once you start connecting these markets, you can start to share reputation, inherit them, markets can begin to talk to each other, tasks can converge. You have all of these different market mechanics across the two sides. So we've had crowdsourced knowledge for decades, and what we're doing at NearTasks is an iteration of existing ideas, but in a trustless and permissionless context of blockchain. So economies will be predicated on the potential and the capacity of both humans and machines to learn, and our mission is to make them inclusive and fair markets. And soon enough, intelligences of all kinds will be exchanging value, and it's for the purpose of iteratively enhancing themselves, whether that's a human or whether that's a machine, to improve oneself, or whether the relationships are human to machine or machine to machine. And not to spat out some doom porn, but many economic experts are making some scary predictions in the not too distant future about economic and financial crises. And one would hope that the goal of these globally impactful exponential technologies like AI and blockchain is to soften the blow of any of these future crises. And they do so by better establishing societal trust. So in conclusion, I hope that together we can grow and invest in our humanness. Thank you very much.